All right, let's talk about a concept that's, absolutely fundamental to how the internet works, but most people have never even heard of it. It's called database sharding, and it's pretty much the secret sauce that lets companies scale for billions and billions of users.
I mean, have you ever really stopped to think about it? An app like Instagram or a site like Amazon, how on earth do they handle all of that? Billions of users, countless photos, just an endless stream of data? How do they not just completely collapse?
Well, the answer isn't just, buy more servers. One of the real secrets, one of the most powerful strategies they use, is something called sharding. It's honestly the key to unlocking that kind of massive scale.
So what is this thing? Let's get into it. Let's break down what sharding really means and how it pulls off this incredible trick.
Okay, so at its core, the idea is actually beautiful in its simplicity. Sharding is just the process of taking one gigantic single database and chopping it up into smaller, faster, and way more manageable pieces. And these little pieces, they're called shards. Each one holds its own unique slice of the total data.
But here's the clever part. It's not a random split. The system uses what's called a shard key, which is just a specific piece of data, maybe a user ID or a customer's location, to decide which shard each piece of information belongs to. So for example, all users with IDs from, say, 1 to a million might go into shard 1. Users from a million up to 2 million go into shard 2. You get the idea.
I know, this can still feel a little abstract. So let's use a real-world analogy to kind of make it stick. Let's think about a library. Imagine a library that has 1 million books all just stored in one single gigantic room. Finding the one book you want, it would be painfully slow, right? A total nightmare. That's like a database that isn't sharded. Now, what if that library was organized into multiple themed rooms? A history room, a fiction room, a science room. Suddenly, you know exactly where to go, and your search becomes incredibly fast because you're only looking through a tiny fraction of the total collection. That's a sharded database.
But, and this is a big but, as powerful as sharding is, it's not a magic bullet. It's not a free lunch. When you go down this road, you're introducing a whole new set of challenges and complexities. There's always a trade-off.
On the one hand, the benefits are just huge. Incredible scalability, much faster performance, and better reliability. But all that good stuff comes with some serious downsides. The system becomes way more complex to manage. You've got to worry about rebalancing, which is what happens if one shard grows way faster than the others. And trying to run queries that need data from multiple shards at once, that is a major, major engineering headache.
So despite all those complexities, the benefits are so massive that the world's biggest companies rely on sharding every single day. The truth is, you're using sharded systems constantly and probably don't even know it.
You really do see this in action everywhere. Instagram shards its data so your feed loads in a flash. Amazon uses these kinds of techniques to manage its mind-boggling inventory and order history. And in competitive gaming, player accounts are often sharded by region to cut down on lag, because every single millisecond counts.
So, if you remember just one thing from all this, let it be this. At the end of the day, sharding is just a strategy. It's about breaking one giant, unmanageable problem into many smaller, independent, and much, much faster parts.
And that simple but incredibly powerful idea is what makes the modern internet possible. I mean it. Without sharding, the global scale applications we rely on every single day, they just couldn't exist.
But sharding is only one half of the scaling story. There's another critical technique that works right alongside it. So what is it? Well, in our next explainer, we're going to explore its partner in crime, replication. We'll compare the two directly. Hope to see you there.